use a simple physical energy, for example, pressure, sound, or microwave energy to modify food structure gently, or to inactivate microorganisms and enzymes, and to design product properties on demand. In a narrow sense, minimal processing refers to non-thermal preservation, processes that maintain the fresh-like quality of food. In a broader sense, it includes all technologies that minimize technological stress on raw materials while still achieving safety and stability. Minimal processing technologies such as high-pressure processing, ultrasound, and microwave vacuum drying all belong to this family. They're based on different physical principles, but they share the same goal: to deliver safe product with high sensory and nutritional quality. In this presentation, I would like to briefly show you the technologies mentioned above. Let me start with the high-pressure processing, which is one of the most established minimal processing technologies. HPP subjects foods to uniform pressures of 100 to 600 megapascals transmitted through water. The pressure acts instantaneously and uniformly, regardless of the shape or size of the product. The microbial effect of high pressure has been extensively studied. The pressure inactivates vegetative microorganisms and some enzymes. Depending on the pressure applied, pigments, vitamins, or volatile compounds remain stable. In our earlier study, we explored HPP in a curing system as a model of pressure-assisted diffusion. We observed that moderate pressure at 100 megapascal can accelerate salt and water diffusion in meat matrices by a factor of 1.5 to 2.4. Microscopic observations revealed a slightly more opened, reorganized myofibrillar structure, which explains the faster salt equilibration and improved water holding capacity. In practical terms, this means a shorter curing time, a more uniform salt distribution, and a softer, juicier texture, all valuable for product development. So in the case of high-pressure processing, we see both the preservation and the processing intensification. It inactivates microbes, and it also has an effect on mass transfer and texture. That's why high-pressure processing perfectly fits the philosophy of minimal processing. The next technology I would like to show you is the ultrasound. The ultrasound typically used in the frequency range of 20 to 40 kilohertz. Its effect is based on the acoustic cavitation. Microscopic bubbles form and collapse in the liquid, creating intense local shear forces and microjets. It's strong enough to rupture cell membranes and the surrounding microstructure. In our recent study, we demonstrated that ultrasound-assisted brining combined with microbubbles significantly enhanced the salt penetration, salt diffusion, and pore formation in pork, which confirming that cavitation can effectively accelerate the salt diffusion. As we can see, ultrasound also improves the penetration of functional ingredients and can reduce the salt levels while maintaining the same perceived saltiness. Combined with vacuum tumbling or moderate pressure, ultrasound represents an eco-efficient method: shorter process time, lower temperature, or reduced additive requirement. Ultrasound also has an effect on microstructure, tenderizing the meat and improving texture uniformity, therefore very useful for example, beef or meat aging. From a product development perspective, ultrasound provides a flexible tool. The same physical principle can be used for meat curing, emulsion stabilization, or extraction of bioactive compounds from different plants. And importantly, it's a non-thermal, energy-efficient process, a true gentle technology. The next technology I would like to show you is the microwave vacuum drying, which combines dielectrical heating with low pressure evaporation. Under vacuum, the boiling point of water decreases, allowing evaporation at 30 to 40 Celsius, while microwaves provide gentle but rapid internal heating. This combination results in very fast drying with minimal thermal degradation. My colleagues applied microwave vacuum drying in a bacon chips product development project. The goal is to create a crispy, shelf-stable product with reduced fat and minimal oxidation. By optimizing the ratio of lean meat and fat, microwave power, and vacuum level, they achieved a light, crunchy texture with excellent color retention and low TBA, low oxidation levels during storage. The process time was less than 1/3 compared to conventional hotter drying. From a preservation point of view, the low water activity ensures microbial stability. From a product development perspective, the gentle drying preserves flavor, color, and allows the creation of a new chips-like product from a traditional raw material. I think it's a perfect illustration of how minimal processing can drive innovation, not only preservation. When we talk about product development today, we no longer think only about recipes. We have to think in process, structure, and property relationships. Minimal processing technologies provide new control parameters, pressure, sound intensity, vacuum level, and microwave power, and so on. By combining these parameters intelligently, we can influence on processes, and we can tailor texture, color, and stability without or lower additives. As we've seen, ultrasound or high-pressure processing can replace a part of the curing time, or microwave vacuum drying allows us to create a new chips-like product. Moreover, when combined with digital monitoring and the predictive models, these gentle technologies can form the basis of sustainable Industry 4.0 ready processing chains. Of course, there are challenges. Scaling up minimal processing technologies requires investment, process validation, and consumer communication as well. Pressure vessels, ultrasound systems, and microwave units demand specialized design and safety control. However, the tendency is clear. As energy costs rise and consumers demand transparency, the minimal processing will become mainstream. The future work should focus on hybrid technologies, different combinations of high-pressure processing, ultrasound, and microwave vacuum drying, and on the development of mathematical models that predict microbial inactivation and, for example, mass transfer behavior. These models can support process optimization and sustainability assessment. To conclude, minimal processing represents an engineering approach to freshness. It allows us to control safety, texture, and other sensory properties through physical principles without relying on additives or high temperatures. The technologies such as high-pressure processing, ultrasound, and microwave vacuum drying demonstrated that preservation and innovation can coexist. The minimal processing shows that it's not about doing less, it's about doing smarter. But finally, I would like to say thank you to all colleagues who participated in the research work presented. Thank you very much for your kind attention.
Thank you very much. Just stay a bit here, Gabor. Maybe we have some questions from the audience. I don't know. Anyone? Yeah. Okay, let's start. While you are thinking.
I have one question. So you do this for the consumer. Is the consumer ready to pay also a higher price for all this food processing? And what benefit is there for the consumer exactly?
Do you mean there is a part of a consumers who wants to buy the minimal processing products? Yeah, it was the. Okay. Yes, there is a part of consumers who wants to pay more, who wants to more pay to get minimal processed products because it doesn't contain additives. Okay.
Okay, thank you. Any more questions? We still have some time. Okay, then let me just ask you another one. These are really smart processing technologies. And would you comment on that the approval of these technologies in the context of ultra processing and the protest against ultra processing? What do you think, are these technologies will fall into the category of ultra processing?
The ultra processed foods and the minimal processed foods are totally different, as we know. The ultra processed foods contains all the heat treated products and contains lot of additives. They are very sensitive in today. Minimally processed products has how should I say? Minimal processed products, it's more important because of, from the point of view, the consumer's health, because of contains reduced additives, contains more vitamins and so on and so on.
Thank you very much.
Thank you.
And
So now we wait for the second speaker, which is Emrah Eruglu from Turkey, I think. So he's already coming. We are perfect in time now. So welcome here. And your talk will be about the optimization of wet agglomeration conditions to improve the physical properties of pomegranate juice powders. Teshik, okay.
Good afternoon, everyone. My name is Emrah. I am from Akdeniz University, Antalya, Turkey. First of all, I would like to thank the organizers of the committee for giving me the chance to speak here. Today, I will be discussing our study on optimization of agglomeration conditions to improve some physical properties of pomegranate juice powder. My presentation plan is provided in this slide. First of all, I will speak about pomegranate powder products, background and some literature overview. I will speak about materials and methods. Then I will give my results and I will try to conclude my presentation. Pomegranate, which is also known as Punica granatum L, is an ancient fruit native to Asia and Middle East, and now it's grown worldwide. It's a member of Litaceae family. It could be processed or freshly consumed. Pomegranate is rich in bioactive compounds and has strong antioxidant and health-promoting effects. As you see, it contains various bioactive components, which is anthocyanins, polyphenols, phenolic compounds, allergic tannins, tannins, and etc. Among these, pomegranate juice is one of the most valuable product in food industry. Powdered products, especially fruit juices, offer several advantages. Compared to the liquid forms, they are easier to store and transport, have longer shelf life, and are convenient for portioning, dosing, and industrial formulation. Fruit juice powders face some challenges because of their high sugar content, especially low molecular weight sugars and acid content. This situation causes thickness and bad flow properties for powdered products. To overcome this problem, carriers like maltodextrin, gamma-arabic could be added to the powders, and anti-caking agents could be used. On the other hand, agglomeration techniques are used to overcome this problem. Pomegranate juice also has similar problems like fruit powders. They tend to stick, and they don't have good flow properties. Carrier agents also used to overcome this problem, but it's not enough for overcoming this problem. If we speak about powder caking, there is different mechanisms for occurring powder caking. For example, we can speak about powder properties, particle properties, intrinsic and extrinsic factors. And if we define powder caking, it is the aggregation of the particle powders particle powders to form large masses. Environmental conditions such as moisture, temperature change plays a critical role for this caking mechanism. Condensed water, especially in the air, plays a very critical role. If we look at the mechanism of the caking, for the three different types of powders, there is different mechanism. For example, for amorphous food powders, capillary condensation plays a critical role. Likely in the crystal forms, capillary condensations, also deliquescence plays a role. How to avoid from this problem, we could control the temperature of the atmosphere and humidity of the atmosphere. On the other hand, we can add some anti-caking agents to the powder, and the other way, agglomeration techniques. Agglomeration is a post-drying technique. With the agglomeration process, particles come together like caking, but this is the controlled one. We have bigger particles with this process, and this improves some physical properties of powders like flowability and wettability. Why do we need to do this? Work? There is a gap in the area of pomegranate juice powder for improving its physical properties like flowability, density, solubility. So we aimed with this study to improve these physical properties, and we plan to enhance some other physical properties. First of all, how we produce pomegranate juice powders. We use pomegranate juice concentrate as raw material. Before the drying experiments, we diluted this concentrate to 12% soluble solid content. After that, we add some carriers, which is 12.5% maltodextrin and 12.5% gamma-arabic on dry basis. And we dried this pomegranate juice with spray drying technique. We used 130 degrees Celsius as inlet temperature and 70 degrees Celsius as outlet temperature for drying experiments. And after that, after we produced the powder, we agglomerated these powders with a fluidized bed agglomerator with a top spray mode. We used gamma arabic as binder solution, and we used 30 minutes agglomeration time. For the optimization approach, optimization procedures were carried out using response surface method, employing a central composite design. Binder concentration and fluidizing air temperature were selected as independent variables. The car index value and particle size values selected as dependent variables. The minimum car index and the maximum particle size values were intended to be achieved. The suitability of experimental data for polynomial models was tested to determine the most appropriate model by variance analysis. Additionally, model accuracy was tested by using R-squared, adjusted R-squared, and lack of fit values. On the powders, we carried out a lot of analysis, but in this presentation, I will focus on only particle size, flowability, and caking degrees of the particles. For caking degrees, powders conditioned at 75% relative humidity for about 90 minutes at 25 degrees Celsius, and after that, they dried in an oven. After that, we sieved these powders from a 500 micrometer mesh, and caking calculated from the powder retained on the sieve and under the sieve. For optimization approach, first we tested different statistical models like quadratic, linear, and two-function interaction. Two-function interaction, which is also called 2FI, model was identified as the most appropriate for our data. The ANOVA results showed that the overall model is statistically significant, and the lack of fit values the lack of fit remains non-significant. The binder concentration has a strong effect on the car index. These findings confirm that the selected model is reliably explains the influence on process parameters for powder flow and particle size. On the other hand, for particle size response, we evaluated several statistical models like the previous one, and we selected the linear model was the most appropriate one. The ANOVA results indicate that the model is statistically significant, while the lack of fit is not significant again, confirming a good model fit. Among the factors, the binding solution concentration shows a significant influence on particle size value. According to the optimization study results, it has been determined that an increase in fluidizing air temperature and binder concentration has a decreasing effect on car index value, which indicates better flow properties. On the other hand, although the air temperature has no significant effect, it was observed that an increase in binder liquid concentration also had an increasing effect on particle size. And the calculated optimum conditions are given in the table. If you look at the results, I give some of the other results, but I will discuss only car index, particle size, and caking degree values of the powders. Car index value of pomegranate juice powders are about 44 and 11 for spray dried and agglomerated pomegranate juice powder, respectively. The car index value of the pomegranate juice powder decreased by 4 times as a result of agglomeration study. According to the table According to the table showing the relationship between flow characteristics and car index, the awful flow characteristics of the pomegranate juice powder has changed to the good. Particle size values of the pomegranate juice powder powders increase about 5 to 20 fold. For example, with our work, the 0.9 value is increased about 17 fold. And as it's seen in this graph, particle size distribution graph, the general particle size of the samples are increased as expected. The green one is agglomerated samples, and the red one is spray-dried pomegranate juice powders. The agglomeration process also decreased the caking degree of the pomegranate juice powder about fourfold, which are about 72 for spray-dried powder. This situation can be also clearly the other part. On the other hand, the agglomeration process has negative effect on powder color characteristics. As you see in the first picture, this was after we produced pomegranate juice powder. However, about 3 months storage, the powder's color characteristics badly has been changed in a bad condition. But their caking properties, as you see, the first one is spray-dried powder, and the second one is agglomerated powder. It was really good for caking reduction. However, as you see, color characteristics of both samples have spoiled as a result of storage and have changed from pinkish reddish color tones to the brownish color tones. And this situation may be related to the oxidation non-enzymatic reactions. So we think that some research must be carried out for improving the color characteristics of powder. As a result of our study, the agglomeration process has been successfully carried out for improving physical properties, but the color characteristics is not included in this one, and the flow properties of the pomegranate juice powder has been improved. The caking tendency of the pomegranate juice powder has considerably decreased. Thank you for your attention. If you have any questions, I will be happy to answer them.
So thank you, Emre, for this very nice presentation. You were also good in time, and now we have place for possibly one question, because we're a bit dense in time. Yes.
Thank you very much. Please tell us why you use the concentrated juice and then dilute at the 12 bricks.
Yes, we can also use fresh juice, but it's not possible to find fresh juice every time. So to produce anytime we want this pomegranate juice powder, we choose to concentrate for producing it. Come.
One more question, okay.
Hello, can you use it for something else? Or it just can be a juice? For example,
Yeah, we can use it for different kind of powders.
Can you use it for sugar replacement?
Right now in this work we didn't use that, but we can use it for producing different kind of powders, but not for sugar replacement. Only for enlarging particle size and having better flow properties. Maybe reduction caking also.
Okay, so Now we might have a small problem. We don't know because we have two people who have to make a lecture, but we don't have the lecture downloaded on the laptop. So we are looking for Csaba Dezső András. If he's possibly here, he should come up and then he can make his lecture. The lecture already? Okay, so the lecture is already. You said here? No. The lecture, yeah. Okay, everything seems to be okay. So Csaba, now try to find your presentation. Wait, somebody comes for help.
Nem akarom, egészen nem látom, hogy hol az egész. Ó, nem tudom, mi felhúztam. Jó, rendben.
So we are ready? Okay. Csaba, let's go. Okay.
Thank you very much. Good afternoon, and please listen to my presentation about the distillation modeling based on the new vapor-liquid equilibrium models. The distillation is one of the most important and then most ancient methods of liquid-liquid separation based on the temperature difference, boiling temperature difference of the components. Basically, it's an ancient method, as I said. Even Egyptian used it. This is one of the picture of the ancient methods, and despite the appearance, this is not organoleptic analysis of the distillate. It's just siphoning of the product from the vessels. Now in the food industry is used basically for the obtaining of the distilled spirits. One of and two examples of recent works about this these books is presented here, and one products with our industrial partner is a strawberry distillate, can be seen in the photo. The basic of the modeling of the distillation is made basically firstly by Warren Kendall in about 100 years, and also is based on the separation of the ethanol from the water ethanol mixtures, and was presented in an American chemical engineering journal. Also, about exactly 100 years, one of the graphical methods still used in our times is presented by McCabe and Thiel, also in the same journal, and is based on the stepping the space between the equilibrium line and the two working line, or the in different cases. And the number of the separation trace is represented by the number of the steps from the graphic. Also in our days is used this shortcut methods for calculation of the dimension, the train numbers of four columns or distillation columns, even for batch or continuous rectification. And this recent article is based on the polyhedral approximation of the vapor-liquid equilibria lines. The train number is represent the possibility, the efficiency of the column to separate the components in better than other one. And this is the main reason to optimize the rectification column. To that, first you need to determine the train numbers. This determination also in every cases is based on the vapor-liquid equilibria data. This one is for ethanol water mixture and taken from the Gmelin database. This and the NIST database is contains almost all determined binary mixtures. All determined vapor-liquid equilibrium data in a tabulated form for all mixtures that had distillate. This is the book that Chemical Thermodynamics Process and Simulation, authored by Professor Mellind, who is the main initiator of the DDBST database. These databases are also used by chemical engineering softwares like Aspen Plus and the others to calculate to modeling of distillation column. And this is a very good but not so accessible software packages. We try to make the calculation accessible for anyone using Excel spreadsheets, and for this we need to develop a new model for vapor-liquid equilibrium. The vapor-liquid equilibria can be represented by the relative volatility of the components, and always this relative volatility has the same equation type, hyperbolic descending and the monotone equation, but in any case, in any special case, the numeric formula is it's a little bit changing. For example, in case of constant relative volatility, the vapor-liquid equilibrium curves can be seen like that. But for any alpha, one is when the liquid cannot be separated by distillation, and for one the relative volatility greater than 1, the equilibrium curve is distancing from it's more and more distanced. In this case, it's very easy to calculate with this relative volatility constant, but the problem is, for example, the alcohol is the relative volatility of the ethanol water system is changing, as you see, the red line, and about in this case, almost the relative volatility is about 1, and changing during the distillation can be changed about 10 or more, or 12 maybe. And this makes it impossible to modeling simple the distillation equation. We try to find some relative volatility function by reverse linear and power law models, and we find that both is better than the original methods with correct Doherty-Malone relative volatilities, as you can see in the exact values of the vapor-liquid equilibrium is represented by the blue dots, and the Doherty model is in the red. You can see the differences. That region, the middle region of the vapor-liquid equilibrium. Our models is better because the standard deviation is much lower, as you can see continue. The Doherty model is represented by the blue dots, and our two models with the red and the green points. But the problem is that not very elegant, this type of equation, because you can handle only with numerical methods in further calculation. And we try to extend this model using for zeotropic and azeotropic mixtures, two models with two models with that hyperbolic function. And finally, we obtain the vapor-liquid equilibria based on this not constant alpha given by the function represented there. And and it's interesting that the Radley-Kister criteria, the Radley-Kister criteria that this x or 1 minus x is appearing without any forcing that. And this is very important because many times this is very important in the chemical thermodynamics for excess function basis. Okay, we obtained both for the zeotropic and azeotropic mixtures the fitting function now in this form, and we try it about 100 binary mixtures. It give very good results. The results was that the error was about 1/10 in comparison with the semi-empirical thermodynamic models. For McCabe-TL numerical methods, graphically, one of the publication used four functions, but with our methods, you can use only one, and you can solve the equation, the polynomial equation, and you have reached with what function what is reached there in the with the four functions. And also, I don't show that, the main, this is the McCabe-TL diagram made with software. The main results of this work that we can represent together the train number and the reflux ratio without any sophisticated software, using only Excel. Sorry, this is okay. For example, for the function of minimal train number, the minimal train number calculation is represented here from the waste concentration and the distillate function of waste and distillate concentration, and the minimal reflux ratio is also represented in the in function of d and xd and x waste. And this is the main results that with a lot of mathematical calculation by integration, you can determine also the number of the train, not only for minimal reflux ratio, but in case of any reflux ratios used in distillation columns. And also can be represented by these methods, can be represented with parametric, the parametric vapor-liquid equilibrium surface, because you know that the vapor-liquid equilibrium depends not only from the composition, but only function of pressure. And in this case, you can obtain for a surface based on these methods. And the conclusion is we obtained a novel fitting function for vapor-liquid equilibria that can be used very easily from spreadsheet calculation in Excel for determination of tray numbers for the batch or even for the continuous rectification column without any expensive and sophisticated software using. Thank you very much for your attention.
Thank you very much. And now it's open for discussion. If anyone has questions. No, then I have one. Basically, when you produce distilled spirits, this distillation optimization is driven by ethanol yield, right? And would you comment on your model, the suitability of your model for optimization of other compounds like aroma compounds? So if the focus is not strictly on ethyl alcohol,
This is problematic because the aroma compounds is represented a very low concentration in the products, but they behave that solutions behave like pseudo-binary solutions. Then the equilibrium lines change a little bit, but basically for the main the obtaining of the core of the main distillate is sufficient to optimize the column tray number. But during the distillation of the fruit distillate, for example, you must change the reflux ratio to optimize the aroma for the products. But basically, this is designed for the separation of the two components mixtures.
Okay, thank you very much. Any other questions? I cannot see. Then I would kindly ask Mohammed.
Thank you very much.
Thank you very much. And Mohammed A. Kelani, if he's here. Interesting. Are you here somewhere? No. Okay, then I guess we have to move on to the next presenter. So I would like to ask Julia Mazar to please give your presentation. So we are grateful for Mr. Kelani because now we have time for the technical difficulties. Thank you. And now the floor is yours.
Thank you, everyone. Good afternoon. My name is Julia Mazar, and today I want to talk about my research work, which is in...
Microphone, please.
Sorry. So, good afternoon, everyone. My name is Julia Mazar, and today I want to talk about my research work, which is investigation of extraction of rosehip active ingredients using microwave-assisted extraction with different solvents. My presentation includes these main parts, which I will talk about in the next few minutes. So, why is important my topic? Because the herbs are enjoying a renaissance, and rosehip is a very popular herb. Everybody knows it has good taste, and it includes vitamin C, but it has other advantages too. For example, includes phenol, antioxidants, several other vitamins, iron, and magnesium. Therefore, use more industry this raw material. For example, pharmaceutical, cosmetics, and food industry. In 2021, the global sales of rosehip product were about $233 million. But in the next few years, the market had grown to $261 million. So we can see a standard rising tendency. But in the same time, the produce of filter generating a huge amount of byproduct and waste, as much as 10 to 40% of the raw material. Therefore, it is increasingly important to address these issues. So my research work's main goal that we find out which extraction method and solvent ensure the most efficient recovery of bioactive compounds from rosehip. During the measurement, we used dry chopped rosehip and two different solvents, ethanol and citric acid. We used the ratio to 10 gram rosehip to 3 milliliter solvents. We choose the microwave-assisted extraction because it has several advantages. For example, enable more efficient, faster, and use less solvent than the traditional method. These extractions were performed according to an experimental design. For the optimization, we used response surface methodology and central composite design, which include 6 measurement points in the center. 3 independent parameters were varying during the measurement. There were the time, the microwave power, and the solvent concentration. The microwave extraction was performed in pulse mode to prevent overheating and evaporation of the solvent. After the extraction, we removed the used rosehip, and after that, filtered with a vacuum filter and centrifugated the sample. The extract were stored frozen until the analyzing. We measured 4 things: antioxidant capacity with 2 different methods, FRAP and DPPH, total polyphenol content, and total flavonoid content. We used the Design Expert software to the optimization. Now I want to present our results. First, I want to show results of the ethanol extraction. We illustrated 3D response surface diagram, which showed a combined effect of solvent concentration and the microwave power on compounds. The third parameter, the time, was fixed. 2 minutes on the diagrams on left and 12 minutes in the diagrams on left and other is right, sorry. First, we can see the antioxidant capacity by FRAP method. This shows that the longer extract time was the better, and the lower microwave power and the lower concentration produced better results. The next diagram shows the antioxidant capacity by FRAP method. This shows a similar trend to the time and the solvent concentration, but here the microwave power is a little bit higher, about 300 milliwatt. Here there are the total polyphenol content result, which shows that optimal parameter there are about 10% solvent concentration, 300 to 400 watt, and the longer extract time. And final, we can see the total flavonoid content, which shows similar trend than the antioxidant capacity by FRAP method. So here the optimum microwave power is lower. This table includes the optimal parameter for individual components. This result similar than we saw in the 3D diagrams. Below the table, there are 4 mathematical models which fitted the compounds. This shows that not only the main compounds, but the cross effect and the quadratic term are significant. These equations are only valid within the experimental range. Here we can see the optimum parameter for all compounds. There were 9.95 minutes, 100 watt, and 10% solvent concentration. The software generated several more options, but when we choose the final consider, we not only want to find the higher compound value, but we want to keep the process cost effect. That is mean reduce the solvent use and lower produce cost. Here I would like to present the other solvents results. So the citric acid. First is an antioxidant capacity by FRAP method. Here we can see that again the longer extract time made better results, but here 3 pH solvent concentration and the higher microwave power made higher value. Next is an antioxidant capacity by DPPH method. This shows the similar trend, but here the optimal microwave power is a little bit lower. These diagrams include the total polyphenol contents result, which shows that the longer extract time, about the 3 pH solvent concentration and a higher microwave power made better results. And finally is a total flavonoid content, which shows similar trend. So the longest extract time, the higher microwave power, and the 3 pH solvent made the best results. This table includes optimal parameter for individual compounds again. We can see that the optimum solvent concentration about 3 pH except the total flavonoid content. So we can tell the acidic medium helps to the extract because citric acid can help break down the cell wall structure. Time and the microwave power are moving a bit wider range if we use this acidic environmental. Below the table, there were 5 mathematical models which fitted the compounds. This shows again that not only the main, but the cross and the quadratic terms are significant. So here we can see the optimum parameter for all compounds. There were 9.1 minutes, 367.83 watts, and 3 pH. Now I would like to present a comparison of ethanol and citric acid. We have already seen that the both solvents have significant efficiency on the extraction time, but yet we didn't check that are significant effect between the different concentration. First, we see the ethanol. Here we can see that are significant difference between all compounds and the best extra solvent concentration about 10%. The other solvent, the citric acid, shows a different trend. Here we can see signification only the total flavonoid content. So the conclusion, our results show that the microwave-assisted extraction is efficient method recovery bioactive compounds from raw sip. Based on that, obtain more time results in more efficient extraction. In the case of ethanol solvent, a 10% concentration was the most suitable. Citric acid has a significant efficient and extracts extract a stronger influence on the flavonoid content. So the both solvent efficient for extraction, but higher compound value could be achieved with ethanol. The effect of microwave powder varied depending on the components studied. In the future, we want to continue this study, and we will test it other environmental friendly solvents and solvents mixture. And we want to use a wider time range in the future. Thank you for your attention.
Julia, thank you for this nice presentation. So, do we have some questions from the audience? Yes.
What do you expect using both solvents in mixture? Do you have some idea? You have some possibility to use both the solvents in different concentration in mixture?
Yes. We want to use, for example, other solvent, a beta-citrodextrin, which I want to mix it with ethanol, for example. So this is the plan in the future, but it has other options.
So further questions, except Laszlo has one.
Thank you very much for your talk. I have a question regarding the citric acid extraction. And yeah, I've never been very enthusiastic about this antioxidant approach, but apart from that, my question is, when you use citric acid for extraction and you use these quite generic assays to estimate the active ingredient concentration, how can you distinguish the response of citric acid and the endogenous flavonoids? So have you considered it? Or because what I think it becomes a part of this pool that responds to these generic antioxidant assays, or maybe I'm wrong.
So, yes, we use two different methods, therefore we get a bigger picture in this antioxidant capacity, because the citric acid have problem there in this situation.
Yeah, it's not a problem, because I think that citric acid is part of that molecular pool that can be considered as an active ingredient, but that's why we have to be very cautious nowadays, I think, to define the active ingredient.
Yeah.
Yeah, okay, thank you very much.
So thank you.
Okay, thank you, Julia.
Thank you.
So this is the last lecture, and she is already coming, I see. This is Gülderen Kozgun, also again from Turkey. So first we have to find the presentation, but this should not be a big problem. Okay, Gülderen, let's go.
Hi everyone, my name is Gülderen Coşkun. I am a PhD student at Akdeniz University. Today I will sharing information about study title Encapsulation of Liquid Amber Orientalis Balsam using ultrasonic emulsification and spray drying. With this project content with our research team. And if you see our presentation content, firstly I will say something about Starax liquids, and then I will explain emulsification and encapsulation techniques, aim of study, methodology, result and discussion, and conclusion. Starax liquids, this is This is a Orioresin excuse from endemic species, tree called Liquidambar orientalis. This tree grow in the southwestern part of the Turkey. Storax liquis is collected from the wounded bark ends manufactured by traditional methods by the located community. This chemical composition of the storax plants have various classes such as lignans, triterpenoids, saponins, monophenols, flavonoids, and fatty acids. I will say SL to storax liquis. SL is widely used in the pharmacological, chemical, and cosmetic industry due to the presence of volute aromatic compounds used for the formation of the perfumes or hearing resin. And SL, as known by Egyptian, Roman, Greek, was used to treat chronic disease like stomachache, asthma, bronchitis, peptic ulcer, as well as burns and parasitic infection for the thousands of years. Several studies showed us this balsam has got an antimicrobial, antiviral, antifungal, antiseptic, anti-inflammatory, anti-hepatotoxic, antihypertensive, and anticonvulsant properties. These properties are associated with powerful bioactive ingredients, especially styrene and stomach acid is very important for this secreture. And the last research showed us SL has been reported to exhibit protective effect against the ethanol-included peptide ulcer in vivo. I will say something about emulsification technique. And emulsification is the mixture of the two or more immiscible liquids. When examining the secreture of the emulsion, it can be seen that two phases. One of the internal phase and the other is external phase. With the energy applied, the particle size of the internal phase decreases and is surrounded by the external phase. The other technique is the double emulsion layer. The force applied to first emulsion reduces the particle size and it is involved by the second internal phase. This technique usually used in pharmacological, cosmetics, and food industry. Because of this secreture, slow and controlled release of the active biocomponents. We are research use of the ultrasonic homogenization, but Professor Gabor said Professor Gabor's speech include of this part. And then I will say something about encapsulation techniques. Encapsulation technique is the common technique for creating an external membrane or coating of the one material over the another materials. Actually, you can see on the first picture, one layer encapsulate symbol, and second is the multi-layer. Core material cover the two different layers, and third, you can see the one wall material has got more than bioactive components. Why we are using the encapsulation in this industry, food industry and pharmacology industry, especially protecting the core material from the environmental factor is very important for us, and then preventing loss by the inhibiting the volubility of the substance, and providing ease of the transformation, mixing, and storage by the converting liquid to solid form, and ensuring the adjusted release of the core material in the target area is important for the topic, because the new research is going to this way, and making the taste and smell of the core material, because of the some materials has got a really uneating aroma profile, but it has got a really huge bioactive component, and preventing core material from reacting with other components, because we are eating or something, and our body has got a lots of reaction. And important things, a bioactive component, it must go to the true pathway. It is used for the purpose as an enable dilution when small amounts are recurrent and ensured homogenization dilution. Actually, why is storage is liquid encapsulated? Because our core material has got a bitter taste, undesirable odor, and high sensitivity to environmental factor and poor consistency. Because byproduct encapsulation SL powder by creating the double layer encapsulation structure, and this structure gives to us mask unpleasant taste and odor, and improve processability, increase bioactivity using the control release system. Methodology, you can see on our methodology, our research has got a two-step. One step, production and characterization of emulsion loaded with storax liquids, and the other steps, production, characterization, and optimization of storax liquids loaded encapsulated storax liquids powdered by spray drying. In this picture, upon the latest examination of the R studies methodology, we use of the Box-Benken response surface methodology. First contained material was keep content at 30% away protein isolation, and independent variables in maltodextrin modified starch ration, storax liquid ration, amplitude, sonication time, spray drying temperature. Preliminary test determined the hemisphere ration 2.5 in this research, and first emulsivation amplitude 50% at 1 minute. The second emulsion obtained was at the drop by drop to carbon gas solution. Specified design under the design has got some amplitude percent, and we made the second emulsification. We use of these parameters, and then. After the second emulsification, we analyzed the particle size, polydispersity index, and the potential value. The obtained emulsification we dried under the drying condition. The drying condition specified in the experimental design. Under our responses, drying yield, we want to maximum drying yield, maximum encapsulation efficiency, and minimum oral release, and maximum gastric release. You can see our emissions, particle size, and zeta potential value. Our particle size value between 101 and 530 nanometer, and our zeta potential values minus 29 to minus 34 millivolts. The results showed us our emulsification. After our emulsification, our structure has got some bronze has got a nanoparticle size. You can see the table. It's so confused. This is a response analysis. But what is the meaning of this table? Actually, drying efficiency between the 70 to 93%. As the maltodextrin ration increased, drying efficiency is increased. Total phenolic content 0.90 to 2.50 milligram gallic acid equivalent gram dry material. Transamic acid 0.80 to 1.17, and we release this information. Storax liquid rates increase. This effect of the total phenolic content and transamic content, and encapsulation efficiency between 30.10 to 71.60%. You can see our 3D response surface graphic, but it's so confused, and I made some graphic in here. The three the graphics were examined more easily, understanding the effect of the independent variables on the dependent variables. A table was created using the 3D graphics to provide a clearer explanation in a short time. Drying yield in optimization, maltodextrin, amplitude, and drying temperature increase, drying efficiency to a maximum. Storax liquefaction and sonication time were found non-significant for this parameter. After that, encapsulation efficiencies as the maltodextrin ratio and amplitude increase and as the SL ratio and the duration decreased, encapsulation efficiency increased. Drying temperature was found to be non-significant in here. And oral release as the maltodextrin and storax liquefaction decreased, the oral release decreased, and amplitude, sonication time, and drying temperature were found to be non-significant. And gastric release as the maltodextrin and the storax liquefaction increased, and amplitude, sonication time, and the drying temperature decreased, effects of the gastric release increased. As a result of the optimization, the program determined the optimal production condition to be 30% maltodextrin, 12% storax liquids, 50% amplitude, and 1 minute sonication time. For the spray drying condition, the 140 centigrade degrees for the drying temperature. It was determined, and actually we our design gives theoretical results for us, and we made the experimental design, and you show that it was determined the experimental and theoretical results were close to each other. And this is a optimum point encapsulated storax liquid analysis results. You can see the emission particle size 396, polydispersity index 0.286, and zeta potential minus 31, and you can see the other things. Actually, the storax is so how can I say, so sticky, and it has got a so bad smells, petroleum aroma, and no one else eats directly. In the traditional consumption is that mix in the honey. And we made this form, the people can be consumed this product, and who want to eat this, he know how much this storax has got, they know actually. And then you can view the scanning electron microscope imaging of the optimal encapsulated SL powder product. In this first picture, the sample which exhibits a Homogenous distribution have achieved at the shape with the independence and protrusions depending on the drying temperature, which has demonstrates their shaping shape. And to the other pictures, open closer examination of the powders, and the independence formed provides an area for small particles present in the secreture to adhere. As a result of this study conclusion, actually, the optimal production condition for encapsulation storax liquids, the bitter taste and petroleum-like odor that limited consumption have been eliminated. The prevention of bioactive compounds throughout the gastrointestinal tract has been ensured. Control release in the gastrate within the gastrointestinal tract has been achieved. The potential for an innovation carrier system applicable in the functional food formulation has been demonstrated. And thank you for your attention. Thank you.
For your talk. And now I'm asking the audience if anyone has any questions. You are waiting for the coffee break. But then I have one question to your talk. This encapsulation is really a fancy thing nowadays to protect the bioactives from deterioration during the digestion. And you also studied the oral and the gastric release protection. And how did you do that? What was the methodology for that?
Actually, we made a response to our PACE methodology. First of all, it's very important test carrier material. We use the balsam and like oil. And first wall material is the whey protein isolate. This really huge emulsification with oil. And then we want to, this product not open in the oral. We want to go to directly gastric.
Yes, but did you have the chance to actually test it?
Yeah.
Again, and how? That was my question.
Actually, we made is the laboratory, but we are continuing this project. We want to, we made it in vivo gastrointestinal static in vitro gastrointestinal analysis, but we want to in vivo and maybe repeat or something. Just the beginning for us or for our team. I will research all of it actually.
Yeah, that's fine. Okay, thank you very much.
Thank you so much.
And it seems that this is the end of the session, so I would like to thank for all the presenters again for their presentation. And now we still have time for the coffee break because we are a bit ahead of schedule, but we are close to the coffee break now. So thank you very much and see you after the coffee break.
Yeah, okay, thank you also from me.
Of course. The stage is yours.
Oh, thank you very much. Which part?
Yeah. This is a pointer you can use during the presentation.
İşte zaten. Hiç bakayım şey oluyor mu?
Yes, it is for the yes.
Thank you very much.
Thank you so
Açılıyor mu?
much.
Düzgün mü şeylerimiz? Bir de ona bakalım. Okay. Tamam, sanki düzgün. Thank you.
Thank you so much.
Nem tudom. Okay. Okay, so on the okay. Sorry. What time do we start again?
20 past 4.
Okay, thank you.
You read this one, am I right?
About you.
Oh, sorry. Okay.
But will we have this or straight to presentation?
Sorry?
Will we have the speech?
Yes. Professor Géza Hitka will start the next session, and after you will read the next one.
Thank you.
Mikor kezdjük Önök úr?
16:20-kor. 16:20-kor.
Időben vagyunk?
Teljesen.
Felrakod az enyémet is?
Hogyne. És te, mint keynote speaker kapsz egy ajándékcsomagot is, úgyhogy... Ez az?
Fogod kezelni? Vagy mi a menetrend?
Hát
Vagy mindig
annyi
a prezentáló tölti be?
Igen, a prezentáló kapcsolja be, vagy indítja el, de hogyha valami fönnakad...
kapcsolva amúgy?
Most nincs, mert különben a karlatok. Hogyha idejövök majd minden előadónál... Hát leginkább annyit gratulál az előadásra, fölkonferálja, hogy jöjjön be, és akkor utána a végén megköszöni, meg akkor megkérdezi a közönséget, hogy van-e kérdés.
Van kérdés rész is?
Ha 15 percig nem tartja az előadó, akkor nincs. Ha 15 perc még marad, akkor lehet kérdezni. Ez a hasznos. Meg azt mondtam még a régi, mindenkinek előre föl kell tenni a prezentációt, meg rá lehet kérdezni, és mindenki föltöltötte, meg aki nem töltött fel, akkor azt nincs. Akkor azt még majd megkérdezted a legelején, amikor én föltöltöttem.
A másik sem, mert ezt is megnéztem, messze, amit persze majd intézem, egy tollfognak még kellene, de látom, hogy ott valami írogatni van.
Nem nagyon kell, az a program. Még rákérdezhetsz az elején, hogy aki nem felmondta a költséget, hogy ezt megkérem. És akkor azt szeretném majd letesztelni, hogy megosztjuk a képernyőt, ugye ott megy a prezentáció, és én meg nekem itt a Prezi alatt vannak jegyzetek, amit csak előadom, igen. Megnézzük, hogy működik a sztori. Én megnyitja a pendrive-ot, a Malte legfőség.
Sose készül. Ilyen beszámoltak például, amikor úgy kell összevadászni, tegnap is kellett egy ilyen ügyes évben, projekt kapcsán. Hát aznap az ilyen valamire felé.
Jó,
meg mindenhol összeszedtem a fotókat. Jó. Meg a át is dokumentáció.
Körülbelül hogy működik. És akkor csak nyílva lépegetek szépen is akkor. Jó. Jó. A technika ördög az nem alszik. Én ezt mindig ki tudom próbálni egy nappal előtte, mert sőt, egy órával előtte. Általában mindig közben jön valami. Ja, most ott ugye nem megy. Most megy. Viszont itt meg nem megy. Érdekes.
Kell egy járni. Kell beszélni? Persze.
Gyere, koppán
Hogy
próbálni.
csak olyan elnököt nevezd. Nem tudom, hogy hol van ez a,
És akkor most nézd meg.
ez a másik úr.
De próbáld meg indítani.
Jó.
Csak hogy itt nem az előadói nézetet látod.
Úgy váltott.
Indítsd ezt tovább, mint hogy jelentsz.
Ilyenkor az van, hogy kicsit túl sok van, akkor lefagy. És akkor amikor a informatikus azt mondja, hogy kapcsolod, lekapcsolod vissza, és akkor
Kontrollált cipőt ad.
Gábor, te a Palotás Pétert láttad itt? Gondolod, hogy ő eljön?
Nem tudom, nálunk is volt azt hiszem kettő, aki kimaradt, az egyiket tudtuk, hogy nem jön. Ahelyett kezdtem én, meg volt egy, aki közben itt a Laci Abramkó mondta, hogy akkor kérje nem tudom kit, és akkor nem jött senket. Jó, akkor kérje a következőt. Akkor ne foglalkozzatok vele, ugorjatok túl. Ki van tolva így.
Na, eltudom, hogy még
igen, ez a jó.
Mi előadások, meg a kérdés, és nem forrás.
Nagyon jó, így.
Nem.
Jó, tökéletes. Jó, akkor a próba sikerült. Csak életben is működjön.
Működni fog.
Nem volt nekem, hogy nem indult az eladás, és akkor elmondtam így, aztán kész. Csak a jobb, hogyha van. Jó, köszönöm szépen akkor.
Ja, a pendrive.
A pendrive, igen, azt teszem szíves. És akkor másik, én mikor kerülök sorra? Még most az eredeti fizetben 17:40 volt írva, most már láttam egy 18:10. Melyik az igaz?
18:10 most a legutolsó, az ebédszünet elhúzódott, és emiatt, de itt látok egy-két olyan nevet, aki nincs jelen, ezért nem tudom, hogy...
Akkor lehet, hogy előrébb fogok
csúszni.
Ki lesz előtte, miközben tenni, hogy azt...
Van olyan...
Igen, de még ő is töltötte fel.
Meg ez a Szafalabidise, a két török hölgyő itt van, a Balotás Péter nem tudjuk, a előtte lévő hölgyő itt van.
Tehát akkor elképzelhető azt, hogy nem 18-10-kor lesz, hanem 17-40-re.
Jó. Sőt, a chairman sincs itt, úgyhogy nem tudom, hogy ki kérte őt fel, vagy milyen információt kapott. Én azt hiszem, hogy megkérem a közönséget, bocsánat, hogy...
Mindegy, én itt leszek, és akkor szóljatok, hogyha én jövök sorra.
Jó.
Óvatosan a lépcsőn.
Jó, köszönöm.
Van ott is neked egy mozgó mikrofon, mindjárt ide.
Ez is működik. Good afternoon. Good afternoon for everyone. The today afternoon session is starting now, so please take a seat if it's necessary, if it's possible. And a few minutes we will start the session of innovation and trends in food sector. So please take a seat if it's possible, and let's enjoy the presentations. Dear audience, we have some missing presentations, so if there is anyone who forget the uploading, please come closer. So good afternoon for everyone. My name is Géza Hitka. I will be the chairman of this session named Innovation and Trends in Food Sector. And today afternoon we have several presentations in this topic, and as I see, 3 of the presenters are missing. So I hope later on they will arrive. If not, maybe it can happen that we will finalize this session a little bit earlier. maybe it's not bad news, but the topics are really interesting, so I'm really sad about this. Also, my vice chairman is missing. I don't know where can he there. So in this case, I suggest to start, and the first presenter will be my presentation. So please if somebody wants to join, can join now, but I think we can start. My presentation title is Future Trends in Food Development, and I would like to show you some interesting about this topic. The first question, how did the food of the future used to be imagined? And I would like to show you some pictures from the past, which was coming different movies and cartoons, and these series, movies, cartoons, the authors imagine how it will be in the future, the food. The first sample is the Jetson family from 1962. You can see a food preparation machine in this picture, and as you see, they imagine that in the future we will buy this machine in our kitchen and we will use to prepare some food. The next one is a Hungarian series, a cartoon, The Fantastic Adventures of Family Mézga, and the topic was in this part to wants to prepare some food for the family. They ask one of the relative from the future, and this relative send a special miracle berry which has different tastes, and after that they eat it and gain weight at the end of the story. Also have another series, The Visitors. It's a Czechoslovak skiffy series from 1983. It was a special canned product in a tube, and after that they push it out from the tube. It start to boiling, start to come up some sausage, some donut, some toast, and the end of the preparation, jelly cube was prepared, and it was delicious, maybe. Also another movie, the Back to the Future second part from 1989. Maybe you remember this product, the dehydrated pizza, which is a really fast method to make a meal. And The Fifth Element from 1997, chicken good, maybe you may remember that. It was a food tablet which was put into a microwave oven, and few seconds the fried chicken was prepared and eat. So that was the past, and that's the imagine how can it happen in the future. But I would like to speak about what is the food product development today, and after that what can be the future from our perspective. The expected product characteristic if you develop a new food product. The first thing is it has to be a longer shelf life and prevention of spoilage. So a prevention is as a goal can come up. Second thing, the good nutritional properties like rich in vitamins or minerals or fiber-rich products. The third one is the consumer health, protection, like, for example, the food safety or the functional foods development. The fourth one, the convenience, easy to open, ready to eat, to-go products, and so on. And the fifth one is the importance of quality, which is based on technological parameters or based on consumer values. So nowadays, this fifth element is necessary to fulfill if you would like to develop a product. And it means that nowadays, if we are thinking the food development, we have to say that it's a consumer-oriented development. And nowadays, we can say the quality is the need of the needs of the consumer. But what about the environmental protection? If we focus on this question, a lot of topics can come up. How can we produce less waste? How can we make production with less energy consumption? How can we substitute some elements, some raw materials, like the plant-based products? Or how can we reduce the package or change the materials of the package? In the European Union, there is a legal regulation in connection with dairy products. So if you develop a product, a substitute product, which looks like a dairy product, it's not allowed to use the classic dairy product names like milk, sour cream, cheese, butter, and yogurt. So nowadays, from legal point of view in dairy products, the almond milk is an almond drink, vegan cheese is a vegan block, or a cottage cheese from eggs, it's a Hungarian product, totu. But what about the veggie burger or the veggie bacon? Now in the European Union, we don't have regulation for this question. But it's a hot topic, and nowadays you can see that a lot of plant-based products come up in the market, and different types of plant-based materials can be used for this product development. Also a question, what should we do with the laboratory-grown meat, which means that sampling a muscle tissue, and after that formation the muscle fibers in bioreactors, and processing the product or cultivated meat as a final product. So is this a meat or is not a meat? What should we do? Also in the 3D printing area, you can see maybe the video as well that the production is really similar. We start from a biomass cell production, and after that we convert into a bio-ink, and we can print it out, this kind of products. It's not, honestly, it's not an animal source, but why not an animal source? We can say that it's an animal source because the basic material is animal cell. So also it's a legal issue. How should we identify this kind of products? Also, the 3D printing can happen in other food processing, like bakery products or pizza making, or some meatball production. And the biotechnology is also available for dairy products because we can use microbes to ferment different whey and casein proteins, and after that we can use water and for example plant fat for preparing the final product, and it can be an ice cream or it can be another dairy product. From legal point of view, it's also a question that we can use the classical name of the dairy products. Now it's not allowed in the EU. Another hot topic for the substitute of meat ingredients, the insects question. Also in our institute there are some research which is focusing on this question, and now if you would like to use these raw materials, or if you would like to develop a kind of product like this, it will be a novel food product, as in the previous one also. So it's also a legal issue that if you would like to go to the market with a product like this, or like the previous ones. IKEA, maybe you know this furniture retail store, develop a menu. They have several restaurants, mostly include the stores, and they have special menus for vegans, like the dogless hot dog. In this product, the bun made from micro seaweed and wheat grass, the ketchup made from berries, and the salad made from herbs, or the bug burger. In this product, the burger meat from beetle larvae, and the ice cream from microgreens. It's also a vegan product. Also question the healthy aspect and the new trends in food innovations, the genome-tailored foods, which means that you can measure different things in your body. So it can be a laboratory test at your home. It can test your blood. It can test your visu or urine test, and after that it suggests you some diet or some special food intake. Also in Europe, not in the focus, but in the world, it's really on the focus, the gene editing. The GMO question, and now there are a lot of solutions. For example, the production of nutrients and vitamin-rich foods, like the vitamin A-rich golden bananas, or the high-protein potatoes, cereals, rice, or the flaxseed rich in omega-3 and omega-6 fatty acids, salad containing iron, or the hypoallergenic peanuts. The enhancing the sweet taste is another topic. How can you increase the taste of the sweet? It's a solution to cover an inert material with sweeteners or sugar, and it will give you the taste that it's more sugar taste without higher sugar content, higher sugar level. Cellulose also can be a food, maybe yes, if you use genetically modified metabolic enzymes synthesized by bifidobacteria that can break down the cellulose in your digestion. Let's eat food waste. This is our next topic. As you know, we have a really big problem about this question. How can we manage the food waste? And usually in our home, it's a normal things that we reuse the menus, reuse the these. But from legal point of view, it's not easy to do it in the EU. But in other countries, they can make some preservation, some packaging, and let's say reuse these kind of meals. Is it possible to consume consumption of spoiled food? Spoiled food is not really good, not just from the microbiological aspect, but also it has a bad taste and bad smell. But can we solve this problem? From scientific point of view, yes. We can use special enzymes which can convert the aroma and the flavor, and it will be not bad for us. And also we can use genetically modified microbiomes, which can help us to digest this kind of spoiled foods. The name of the project was the hyena inhaler. And go back to the university. Some research topics are also running in our university, like the sous vide preservation technology, like the high hydrostatic pressure technology, or the active ultrasound technology for curing, or the dry aging technology, development on different egg products, or the post-harvest technologies. And I hope today and tomorrow you will get more information about these research results. Also, key question, the sustainable packaging, and also we have some research in this topic in our institute, like the using of edible coatings, the biodegradable packaging, different nanosensors, for example, to detect the deterioration of meats or fruits and vegetables, and the RFID and nanobar codes technology for example, the traceability. Also, the alternative agriculture is a question, and also in this institute we have some program which focus on this question, like the vertical farms or the rooftop farm questions. And nowadays we can see projects which are working in a larger scale, different part of the world. So as I see, and maybe as you see as well, there are a lot of new trends in food development, and I hope maybe you will get new ideas for the future researches. And thank you very much for your kind attention. And now we have few minutes for questions if you have, or if you would like to speak with us in the coffee break or after the presentations, we have time to answer your questions. If not, I would like to ask the next presenter, Ira Joy Aquino. Hello, welcome. And I tried to help her. If I found the mouse. Okay. Which one is yours?
Will I get the free? Okay. Thank you.
Just a moment. Okay, and I sent you.
Okay, thank you. Yana Potkivanok. Good afternoon, everyone. So I am Ira Joy Aquino from the Department of Applied Food Science, University of Veterinary Medicine, Budapest. And today I will be presenting the consumer-driven shelf life determination and consumer perception of chicken samples. So this project is under the MicroOrg EU-funded project, coordinated by the Norwegian Institute of Food, Fisheries and Aquaculture, also in partnership with Universidade Católica Portuguesa. So just a short background that there is a recent EU study involving 25,000 EU consumers, and they segmented the type of food wasters in the EU. So they segmented 3 types of food wasters. Firstly, the unconcerned, pragmatic, aware food wasters. So they also ask these persons how they check the date label marking, and if they correctly follow the use by and best before date. And a common thing among these 3 type of food waster is that they have a low understanding of the use by and best before dates. And also to note that 10% of food waste in the EU is linked to date marking, and the total of food waste in the EU is 58 million tons. Also in this project, so we did a semi-structured interview among chicken producers in Hungary, Norway, and Portugal, and we determined that they determine the shelf life of their products through microbiological tests, sensory tests, proper packaging, quality assurance, but they don't employ consumer testing. So the objective of our experiment is to characterize the changes in consumer perception over different storage time and identify at which time point does the product is deemed unfit for consumption. So we want to assess the relationship between this consumer acceptability and other product parameters. So with all this data, in the end, we want to create an industry-relevant shelf life determination method or guidelines that is fit for the industry. So we will be doing this type of experiments, and we will be also doing surveys here in the project. And all of this data will be used to create the goals of the projects like predictive analytic model, smart packaging technologies, rapid detection assay, microbiome-based protection technologies, and novel packaging solutions. So for the methodology, we will store raw chicken samples in a reverse storage design method. And then we will do the experiment like sensory analysis, consumer testing, and later we will do analysis like survival analysis and estimate cutoff point. And today I will present some of the data that we already have. So for the sampling, in Hungary, so we have different types of packaging. So in Hungary, we have the vacuum packed chicken, and the size of the package is 1 kilogram or 4 chicken breasts per package, and the shelf life in the industry or in the chicken in the market is 10 days. So we have 2 sampling scenarios, so 4 degrees and 8 degrees. 4 degrees is the cool temp, and 8 degrees is the abuse temperature. And you can see also there are different days or sampling days. So in Norway, they have different packaging type, packaging scenario as well, and they have 20 days shelf life. So Portugal, a different packaging scenario as well, and different sampling days and points. So again, just to highlight, we have 2 scenarios. First is the cool temperature at 4 degrees, so the usual refrigerated one, and the abuse temperature of 8 degrees. So in Hungary, for the consumer test, so we have 117 valid consumer data, and we have semi-trained panel for the sensory analysis. For Norway, they have 115 valid consumer data, and they have trained panel. Portugal, semi-trained panel as well, with 121 consumers. So for the consumer acceptance results, so we have the mean odor of the raw chicken and also disliking. So the consumers scored the chicken. So on the right, we have the disliking, and on the left is the intensity or the odor intensity. And the blue line is the 4 degrees, and the red line is the abuse or 8 degrees. So you can see that the intensity and disliking odor increases significantly from day 8, and at abuse temperature, it started to increase from day 7. And this one now is the most disliked and most intense odor sample from day 18 to day 15. We also have a replicate at day 7, and both of them has 87% acceptance response, meaning that we have good replicability with our data. And there's no significant difference between the 4 degrees and 8 degrees, so it doesn't really affect the storage condition, doesn't really affect our data. For Norway, so similar, for the cool temp, the intensity and disliking score increases much later, which is started from 18 days, and at the abuse temp from 15 days. So the worst samples were from 23 to 27 days, and for Norway, the 8-degree samples have higher odor intensity and disliking, so the storage condition does affect the data. For Portugal, it started from 11 days at the cool temp, and similar to Hungary, 7 days for the abuse temp. The worst samples are 11 and 17 days, and similar to Norway, the 8-degree samples have higher odor intensity and disliking. So this is just a summary of what I've discussed so far and will be discussed later in the conclusion as well. So now this is the sensory data from the semi-trained and trained panel. So for Hungary, so you can see on the right the different storage days, and as the color intensifies, so the storage days also increase. So the higher the storage day of the chicken sample, the higher the score. So we have different attributes, including total intensity. So we have 11 attributes in total, and then they were scored in a 9-point hedonic scale. So just the trend, I want to show you that these scores, as the storage days increase, it also increases. And some of the highest attributes are total intensity, cloying, and sour and fermented. So in Norway, it follows a similar trend. So the more storage days, the higher the scores. They have the total intensity, the sulfur and cloying attributes score the highest. And for Portugal, it's also similar, and they have total intensity and cloying attributes scored the highest. So microbial analysis. So this is the data for Hungary. The blue one, again, is the cool temperature, and the dotted line is the abuse temperature, data for Norway, and data for Portugal. So for the 3 countries, there are higher counts for the abuse temperature. So this is the total microbial count. And in general, the total microbial load increases with the storage time. We determined also what type of microbiota they have in the chicken. So for Norway, we determined Carnobacterium, for the coal, for the abuse, Hafnia. For Portugal, we have Rhocotrix and Serratia. So these are typical spoilage for chicken. But in Hungary, it's quite interesting that we found this Photobacterium for both scenarios, which are usually found in fishes. And we only determined this after the microbiota, and it was not detected or discovered by traditional method for analyzing the poultry. So in summary, so the sample with the longest storage time does not always have the most intense odor or smell, because the 8 degrees usually gave the more intense odor and smell. And for the microbiota, so there are higher counts for the abuse temperature. And as you saw, the samples from the 3 countries have different microbiological composition. But they agree that the microbial load increases with the storage time. So for concluding, the higher the temperature, it accelerates the spoilage, but the effects vary by country. So the odor intensity and the disliking increase with time, but the timing is different per country. So with Norway, the increase is much later, like 18 days. But for Hungary, it started at 7-8 days. And for Portugal, for cool temp, 11 days. But the abuse temp, similar to Hungary, only from 7 days. So the sensory changes don't always match the microbial shifts. So both methods should be employed if possible. And the microbial load drives the overall odor intensity, but the link to the sensory change needs to be studied. So, but we should interpret this data carefully due to limited sampling points, and also consumer has variable tolerance. So for future work, we will do further analysis for this data to determine which attributes are relevant. So we will do PCA, cutoff point, survival analysis for the consumer data. And in the end, so we will use all of this data to create a shelf life determination guide for the industry. And also we will do sustainability assessments, data about food waste, because aside from this, as I've said, we are doing, or we have done already the data collection for the Pan-European Digital Consumer Survey. Thank you very much. And if you have any questions or want more details about the project, so we have our website and our LinkedIn. Thank you.
Thank you very much for your nice presentation, and also thank you very much the time management. It was perfectly 50 minutes. So is there any question for the audience? I have only one question, that usually this product we use a safety rule, let's say, that we not keep the product till the end, because of the cold chain can
Yes.
destroyed or something can happen with the product. So did you thinking about this rule, how many days has to be left to be safe for the consumer this kind of product?
Yes, so that data I didn't present it, but it is in the survival analysis and cutoff point data. So as I remember, for Hungary, it's only safe, for example, 10 days is the usual,
Yes.
but what we found so far in our data is it's only safe until 2 days based on the data from Hungary. But for Norway and Portugal, for example, they have higher allowance after the expiry or the actual best before date of the products.
Thank you very much.
You're welcome. Thank you.
Thank you very much. And as I see, the next presenter is not here. Peter Palotas, as I see, is not here. So I would like to ask Özgül Altay. Hello, welcome. And please come to the stage. Melyik ez? Délután? This one? Okay. I try to set that.